You ever find yourself at an airport, you look out at the tarmac, you see a big modern Airbus, and you think to yourself, that belly part looks kinda chunky, doesn't it? Well, today we are going to dive into why that seemingly awkward shape is actually a secret masterpiece of aerodynamics, a design trick that goes all the way back to the dawn of the jet age.
I mean, it's a totally fair question, right? You look at the sleek nose, the graceful wings, and then there's this bulge underneath. It just seems to go against everything we think we know about how to make something slip through the air efficiently.
And hey, you're not the only one who thinks so. It's a really common observation. It just doesn't look fast. But here's the thing about aerodynamics. Looks can be incredibly deceiving. And the real story here is so much cooler than just what our eyes are telling us.
All right, so to get to the bottom of this, let's start with the obvious stuff, the practical reasons for this shape. Because at the end of the day, a huge part of designing a plane is just figuring out where to put everything.
So that chunky fairing, it's not empty space. It's basically the plane's utility closet. You've got the wing box in there, which is the super strong structural core that holds the wings on. You've got the bays where the massive landing gear folds up. You've got all the ducts and pipes for air conditioning. It's basically a very, very full basement. So yeah, part of the reason for the bulge is just it's full of stuff.
But, and this is a big but, that's only half the story. That's the simple, practical answer. The real reason, the genius behind that shape, is a mind-bending aerodynamic principle that engineers figured out when they were trying to solve a very, very fast problem.
And for that, we need to hop in the time machine. We're heading back to the early 1950s. This was a wild time of sleek new jet fighters that were designed to push the absolute limits of speed, only to find themselves slamming into a completely invisible wall.
So imagine this. You've built this gorgeous, powerful jet. It's got a massive engine. It looks like it could punch a hole in the sky. But every time it gets close to the speed of sound, Mach 1, it's like it hits a wall of invisible molasses. A huge, mysterious drag force just appears out of nowhere, and the plane just stops accelerating. It was a puzzle that was driving the best engineers in the world completely crazy. And then along comes our hero, a guy named Richard Whitcomb. He was an engineer at NACA, which was the precursor to NASA, and he had this flash of genius. He realized that everybody was obsessed with making the individual parts of the plane aerodynamic. You know, make the wings skinny, make the fuselage pointy. But he figured out the problem wasn't the parts by themselves, it was how all the parts added up together.
And the perfect proof of this was a plane called the F-102 Delta Dagger. The original design, with a totally straight, logical-looking fuselage, just could not go supersonic. It was a failure. So Whitcomb's solution was completely bonkers, totally counterintuitive. He said, let's pinch the waist of the plane, right where the wings stick out. This gave it this famous Coke bottle shape. And guess what? With the exact same engine and wings, the redesigned plane didn't just break the sound barrier, it blasted right past it with no problem.
So what was this magic trick? What was this secret sauce he discovered? Well, it turned out to be a fundamental rule of high-speed flight, a rule that designers still live by every single day. It's called the area rule. Okay, now stick with me here. What it says is this. To fly efficiently near the speed of sound, you have to imagine taking a slice through your airplane at every single point from its nose to its tail. The rule says that the total area of that slice, fuselage plus wings plus tail, whatever's there, has to change as smoothly and gradually as possible as you move down the length of the plane. So here's the key. It's not about being fat or skinny. It's about how quickly you get fat or skinny. When you have a straight fuselage and then bam, the wings suddenly appear, that's a really abrupt, sudden change in the total area. That sudden change creates these powerful shock waves, and those shock waves create a type of drag called wave drag. It's an absolute killer for efficiency. Now you might be thinking, okay, that's cool for a supersonic fighter jet, but an Airbus isn't breaking the sound barrier. And you're right, but here's the thing. It gets really close. Modern airliners cruise at about 80 or 90% of the speed of sound. They live in that tricky transonic zone where these exact same effects are happening, just in a subtler way. And for an airline, minimizing that drag means saving millions and millions of dollars on fuel. So now we can finally bring this all back to that chunky Airbus belly. Because that bulge isn't some clumsy afterthought. It's not a bug, it's a feature. A very, very clever feature that's a direct application of Whitcomb's area rule. So here's the big reveal. When we look at the plane, our eyes see a clunky bulge right where the wings meet the body. But the air sees something completely different. Think about it. Right at that point, you have the fuselage, and then you suddenly add the huge area of the wings. The total cross-section spikes up massively.
That big belly fairing is perfectly sculpted to add extra area before and after the thickest part of the wing, smoothing out that spike. It is, quite literally, the airliner version of the Coke bottle fuselage. It's filling in the valleys to make the mountain look like a gentle hill.
You can almost imagine the Airbus talking, right? Yeah, I know. I look a little chunky right here. It's on purpose. I'm area ruling. And I'm saving a ton of fuel while I'm at it. Thank you very much. It's a design of pure function. It couldn't care less about looking pretty to us on the ground. It's designed to look pretty to the airflow at 35,000 feet.
And that right there is the big takeaway. In aerodynamics, efficiency is elegance. Function creates its own kind of beauty. That shape, which might seem blunt and awkward to our eyes, is incredibly graceful and streamlined from the only perspective that actually matters, the air that's flowing over it.
So the next time you're at the airport and you see an Airbus rolling by, take a good look at that belly. You won't see a clunky bulge anymore. You'll see a clever, fuel-saving masterpiece born from the race to break the sound barrier. You'll see the hidden elegance of a design where what really matters isn't how it looks to us, but how it feels to the air itself.